So again, this is a snapshot from yesterday. Um, I'll just copy them onto the TV here. I think that'll be more efficient. So first one has just the one fraction that we want to get rid of. So make sure you're focused and not distracted by anything else, okay? So the only thing we want to do in this problem is kill this one fraction, and it has a bottom of 3. So we're going to monster bracket this whole equation and multiply by 3. Anyone have any questions about that? All right, when we do that, it's going to multiply into a couple of different places. The first place it's going to go is right here, and that makes negative 30. And then we're going to copy down the equals sign. The second place it's going to multiply is right here. And I wanted to make sure that there was one of these on the snapshot where when the number that is the fraction killer and the fraction collide, all that's left over is a positive 1. And that is a meaningless 1. So I don't need to put the 1. I don't need the parentheses. Again, this 3 that I'm circling in purple and this 3 that I'm circling in purple, they cancel each other out, leaving us with just the 2x minus 7. It's really important that you ask questions along the way if you have them. I would be happy to stop and explain why I did what I did or how I did what I did, okay? That's your job. Now that we get to here, it's no longer a fraction equation. It's an equation from the last quiz. I'm going to add 7 to both sides. And I'm going to get 2x on this side, drop, drop. Negative 30 plus 7 is, of course, negative 23. And then I'm going to divide nice and neat by 2. And that's going to present me with my final answer. All right, we know from just common sense that 23 can't divide by 2. To be able to divide by 2, you have to be an even number, and 23 is odd. So I'm going to just get x equals negative 23 halves. And that's it. No questions on that one? Okay. For the second problem, I'll do it over here. We have 4 equals 3/4 times the quantity of x plus 5. This is effectively the exact same problem over again, but again, I wanted to check up and make sure that you understand that there is a leftover when the fraction killing takes place. So when I monster bracket this and I multiply by, of course, 4, the 4 will multiply to 2 different places. First, the 4 will multiply here and give me 16. And then the 4 will multiply here. And the entire purpose of that second multiplication is for this 4 that I'm circling and this 4 that I'm circling to cancel each other out. We do this time have to drop down the 3. It's not meaningless like a 1 would have been. And then we do have to now keep the x plus 5 in parentheses because that 3 is going to be a multiplier. Good. I hope each of you are finding your own sort of issues. I mean, it's hard. You each have your own needs. So hopefully you're focusing on where you went wrong. And then again, from here, it's no longer a fraction equation. It's a 2 weeks ago equation. I distribute 3 on the right side and I get 3x plus 15. And then I subtract 15, nice and neat on both sides, like this. Cancel those out. Drop, drop. So I'm going to drop the 3x. I'm going to drop the equals. Then I'm going to worry about the math. 16 minus 15 is, of course, 1. And then I divide both sides by 3. And contrary to popular belief, the answer is not 3, right? That happens a lot in high school where people think, oh, I see a division problem and there's like a 1 in it. So if someone told me just to keep the number the same, that's a bunch of hooey, right? 1 divided by 3 cannot be 3. It doesn't make sense. The answer is 1/3. You can't divide $1 by 3 people and expect everyone to get $3. It just doesn't make any sense, right? So do you have any questions on the first 2, that top row? Those are cut from the same cloth. They're just a single fraction kill, nothing to it. All right, let's head on to the bottom row. These are multiple fractions. So this time we have to go a little bit bigger. We have to think a little bit more creatively about how to accomplish our objectives. So we want to kill both fractions simultaneously. You, sir, listen carefully, please. Not using your name since I'm on recording here, so Yeah, listen carefully. I want to pick a number that can kill both of these fractions at the same time. And I'm thinking of something called the least common multiple. You guys also call it the least common denominator. What is it? It is 10. So I say 10 can be divided by 2 evenly, and 10 can be divided by 5 evenly. So that's how I select the number that I'm going to use. I want to make sure that both my fraction killed divisions come out to whole numbers. That's the goal. You could also use 20 or 30 or 40 or 50. You could use 100. You're just asking for more trouble at the end if you use anything bigger than the smallest that you have to. So it's not wrong if you go bigger. It just has to be divisible by both. I'm always going to pick the smallest one because I don't like reducing fractions more than they have to. When I multiply by 10, its first multiplication happens here. And it's not really multiplication yet. That will come in the next step. All I need to do right now is take the fraction killer 10 and divide it by the number that's on the bottom. 10 divided by 2 is? So I write down the number 5. And then I express to the world that in the next step, I will multiply that leftover by whatever was on the top of the fraction, right? And then I head to the next one. Next step is you take the sign in the middle and you copy it down, just so we know now that we're going to be dividing and having a positive when we're done. And then in the second iteration of this process, the 10, the killer, and 5, the bottom, what's 10 divided by 5? So we put down a 2, and then again, we copy down what was inside. Do not skip that step. On the other side, I also have to multiply by 10. That was a common mistake I saw, was people totally knew how to kill the fractions, and then they copied down x minus 2. It's like, whoa, dude, you can't do that. The 10 has to multiply here and here. Everyone that's out and exposed is going to get smacked by that fraction. So we're going to get a 10x and a minus 10 times 2, 20. Again, the fraction killing being complete, this is now no longer a fraction equation. From here, it's hope and pray that everything before this went well and that you know to distribute, combine like terms, so on and so forth. So on the left, I'm going to distribute. I'm going to distribute my 5 and get 15x plus 15. In the second half, I'm going to distribute my positive 2 and get plus 6x minus 2. And then I'm going to copy down the rest of the junk. And again, the inclination, what I have to try to coach out of you in August and September is the urge to say silly things like, ooh, let's subtract 6x from both sides. I got to coach that out before we get to October. Stop that. You need to look at the left side of the equal sign right here as its own little island and say, what can I just do locally right there? And the answer is, I'll put some stuff together. I see 15 x's and plus 6 more x's to make 21 x's. And I also see positive 15 minus 2, which makes 13. This is what we strive for, we algebra people. We strive to get you to that point where now the left side and the right side on their own are the best versions of themselves. Now we start thinking in terms of the words both sides. Who's smaller, 10x or 21x? Yeah, I never mean to insult you when I ask those questions, but we want to focus on the smaller x. So I'm going to take away 10x from both sides because it's a positive 10x that I'm trying to kill. On the left, I'm now left with 21 x's minus 10 x's, which is 11 x's. You'll notice my equal sign is not in a straight line. Sometimes it just happens as long as we're structured each step. Every time you do a step, you're making a new math problem that's a little shorter than the one before him. And then from here, I would subtract 13 from both sides. Drop your 11x, drop your equals, negative 33. Last step, of course, divide by 11, and you are done. Any questions on that one? Probably give you another one of these coming up soon, not today, but just to make sure that this is getting home. And I'd like to see way less red ink on those papers next time, okay? Let's do one more problem. There's that last one to go. I'll just scoot this over for those of you that are still copying things down. So we have x plus 1 over 6. Ooh, you knew this was coming. A minus, that's the killer, 3x minus 7 over 9 equals negative 1 over 18. So this is kind of next level now, right? We have traced 3 fractions that we have to kill. So I ask you the question again. When you say things like 3, it just tells me that I'm not saying the right words. I'm not looking for what they can all divide by. What's the smallest number that can divide by all of them? 18. You could use 36 or 54 or 72. You can use any multiple of 18, but 18 is the best because it's the smallest. And at the end, it will leave me with smaller numbers, and everyone likes that. So 18 is the smallest number in the universe that can divide evenly by 6, 9, and 18 and not leave a fraction behind. And here we go again. So when the 18 multiplies into the first one, what is 18 divided by 6? So I write down the 3, and then in parentheses, I copy down the top. And this is where you fancy pantsers that think you should skip this next step really pay the price. Don't skip this step. Copy the minus down. That's important. And then do the little rinky-dink itty-bitty kitty division. What is 18, the red number outside, divided by the bottom 9? So I write down the 2, and then in parentheses, I copy down the top of the fraction. And then on the other side, the 18 also applies himself over here, and those 18s cancel cleanly, leaving behind what? Negative 1. Both the negative and the 1 are untouched. The 18s just whoosh, killed each other out, leaving the negative 1 to drop down. And yet again, we find ourselves without fractions. Let's distribute. 3x plus 3, and here it is. This is it. This is it. Minus 6x, right there. You force me to bet $1,000. If someone said a kid missed this problem, I'll bet you $1,000 if you can tell me where they missed it. My money every single time goes that they put minus right there. And that's just disrespecting the negative. When we copied that minus down about a minute ago, he says, don't forget me, because I'm going to become a negative. And when you distribute me, you're going to have to change all the signs that I smack. So as a guy that's been sitting on this side of the desk for a really long time, take it from me. Respect the minuses, respect the negatives. Let's press on now. The rest is just, business as usual. Combining like terms on the left gives me negative 3x, because 3x minus 6x is minus 3, or negative 3x. Combining my constant terms, that's the 3 and the 14, gives me 17. And now it's time to let the sides go together. The 17's like, move me over there. I want to be with my homie, negative 1. So I'm, okay, that's a good idea. Thanks, 17. So I subtract the 17 to make him go bye-bye. And I'm left with my negative 3x equal to a negative 18. And then I divide, of course, by negative 3, resulting in x equals 6. So we'll do another snapshot over this probably tomorrow. I'll start class probably by saying, let's go again. And I want you to show me that you've learned this. And if you feel right now like that still isn't the case, there'll be maybe a little time in class today after the lecture, and there may be time during, of course, there's flex today. And of course, I can stay with you after school as well. But let's get you to a point where this doesn't start to pile up, because today's is harder. Okay, cool. So I'll just keep the same video going. We're going to take notes. Today is the 19th. And the way I want to teach today is by opening up Delta Math and putting problems up on the television. So when I find a good one, as a teacher, I can just click new problem, and then I'll stop when I get to one that's like something we haven't seen yet in the notes. and I'll stop and we'll work that. You'll just copy it into your notes and we'll work it together. The reason this section is harder is because the problems are not like that. You would agree, if you understand it now, looking at that last snapshot, that there's just two kinds of problems. It's like, do you do this or you do this? It's like they all kind of feel the same. These ones come at you in a lot of different ways. So this will take a little bit. And if you have questions, let me know. This will be scary for some of you. I'm just warning you. I like to run interference and let you know. So these are the hardest fraction equations that we'll do. FYI. So let's just start with this one. And I'll zoom in, by the way, so you can a little better look at it. I'm going to try something this year with you. You know, you're never too old to try new things. I'm going to try to teach this differently than I have in the past. Miss Orozco will remember this from last year because, you know, she was in my algebra class last year. And I'm going to try a little bit of a different approach. And you can let me know if you like this approach better or worse. I'm going to pause this and answer my phone. It's 2 times the quantity. If you can't see, you need to sit closer, okay? 2 times the quantity of negative 1/2 x plus 6/5 closed quantity plus 3 equals negative quantity, negative 3x minus 1/5 closed quantity minus x. All right, it's going to be super inefficient if I have to read these off super slow to you. So if you cannot read the board, that's zoomed as far in as I think realistically I can go. You'll need to switch. There are a couple seats up here that are much closer, so that's pretty big. So today you learn the fine art of deciding between which fractions are killable and which fractions are not. And this first couple minutes is critical. You'll notice now that we have a new sort of intruder. You see it? There are parentheses. And as you know from previous work, parentheses are like protectors. And when I put on my monster brackets and I multiply, like I may initially look at this and say, I want to multiply by 10. The problem with that is the 10, if I fraction kill, actually can't kill those fractions because the fractions that I want to get to are hiding from me. So the way I used to teach this, I'm going to show you this and you can write this down and you can tell me if you like this. I'll probably maybe waffle back and forth throughout the period here. But the way I used to teach this is just move through, distribute through, accepting that we're going to get fractions and deal. And if I do this step and you think that's easy, then maybe I'll just proceed. But I have a backup plan if I need it. So what I'm thinking here is I look at the outside of the parentheses, and if there's parentheses, that probably means that there's something that has to be distributed, right? That's what the parentheses are for. So what I'm going to do in the first batch, and you won't like this very much, is I'm going to take the number 2 and I'm going to multiply it here, and I'm going to multiply it here. And again, if you do not like this, it's important that you let me know because I have another plan. I've never done it before, but I thought, let's give it a shot. So the problem with this is that if I multiply by 2, then it won't kill the second fraction. And that is uncomfortable for a lot of us. So in the first red arrow, can you guys tell me what I get when I multiply the 2 by the negative 1/2 of x? I get negative 1x, also known as just negative x. That's just the 2. And this isn't me purposely fraction killing, air quotes. This is just, I'm just doing what the problem laid out for me to do. So I'm not attacking anything with any particular purpose. I'm getting rid of the parentheses. This is the part you won't like. Now, if I multiply 2 by the second fraction, I'm not lucky enough to have my 2 and the bottom of the fraction cancel each other out. You see? Because you're like, yeah, it doesn't take a math degree to know that 2 and 5 don't divide by each other, right? 2 can't divide by 5. So with that said, I'm going to write down what the answer is, and you tell me if it makes you physically uncomfortable. What I just did really quickly is I took the number 2 and I relied on my old grade school knowledge. And I said, okay, to multiply two things, if one of them is a fraction, they both have to be fractions. So I took the number 2 and I made it in my mind into 2 over 1. I'll write this for you off to the side. I took the 2 and I thought of it like this. And when I multiplied it by the 6 over 5 like this, do you see how the 2 and the 6 can't reduce with the 5? Do you also then see that if you just multiply across the top and the bottom, you get 12 over 5? How terrible is that? Could you do it? Let's press on, and then I'll come back and show you another way to do step 1. And I would love your feedback after I show you the other way, because again, I've never taught it this way before, but I thought, let's give it a shot. So let's press on with this. That's the worst of step 1, because I'm going to copy down the +3, of course. I'm going to copy down the equal sign. This one is easy peasy because what's being distributed into the second parentheses? Just a negative. And I'm not scared of that. Like, this ain't my first rodeo. Like, I know that a negative is just going to be a sign switcher. So my negative 3x is going to pop out to freedom as a 3x. And my minus 1/5 is going to pop out as a plus 1/5. And then I'm going to copy down the minus x. Yep. What's up? Yeah, what's up? This is what I did last year. And now if you want to, if that first step doesn't bother you at all, this will be your go-to. I'm going to show another one here in a second. But if that did not cause you any physical angst, now, yes, of course, now you would put a set of parentheses around this whole equation. And what would you multiply by? 5. And fractions are dead. You're on your way to freedom. Game over. So if this caused you no grief, consider this probably the method that you'll choose throughout this. The people that are going to run into issues are the people that really, really freaked out when I did this times this. And I wish that weren't the case, but sometimes it is. So let me show you an alternative strategy, because I don't really want to finish this. Like, you guys could do this. You could multiply by 5, and it would multiply boom, 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 all 6 places, and then you do your thing. Easy peasy. So here's my other method. And if you don't like this one, then I have no other options for you. I'm sorry. So here's what I'm thinking, and tell me if I'm crazy, is I'm thinking what I want to do is I want to place a number here and here so that when I distribute into my parentheses, those numbers that I'm going to strategically place there, that number will be able to satisfactorily kill all of the fractions inside. So if I was going to distribute something that has to kill fractions with a bottom of 2 and a bottom of 5 and another bottom of 5, what number would have to be placed in front of those parentheses? Tens. You agree? So what I'm thinking now is I'm going to, and I, like, again, never ever even done this. Not even in my own time have I ever done this before. I think this method is wacko, but it might help some of you. So I'm going to take this entire equation right now, and I'm going to buff it times 5. Now, yeah, I hate this. This is already making me physically uncomfortable. I can already taste my dinner from last night. But anyways, if I do this, when the 5 multiplies here, 5 times 2 is now 10. And then I copy down the innards of the parentheses like this. 5 also has to multiply here to give me 15. 5 also has to multiply here to give me -5. And then 5 also has to multiply here. Like I said, that's the first time. I just sailed that ship on her maiden voyage, and I'm thinking, that's crazy. But the good news now is that if you distribute those numbers that are in front of the parentheses, what won't you get? Fractions. So you effectively run interference on the front end to kill the fractions. So here are your options. You can distribute and then kill the fractions, or you can recreate numbers and then kill the fractions. I don't care, as long as you get rid of the fractions correctly. So now that I've got my correct numbers in place and I distribute, here it goes. Follow the purple arrows and you'll see goodness comes. And if you can't do this, then you and I have much bigger fish to fry because you're in a high school class and I need to know that you can do 10 times negative 1/2. What is 10 times negative 1/2? It's -5, right? The 10 and the 2 cancel to leave a 5, so that makes -5x. Follow the second purple arrow. Again, right here, second purple arrow. The 10 and the 5 on the bottom, what do they divide to make? 2 times 6 is 12. You should stare at that until you're sure you understand how that happened. Let me circle using green. This 10, the green one, and this 5 divided. Again, what is 10 divided by 5? Grab that leftover 2, swing it in and multiply it by the 6. On top, 2 times 6 is, there you go. By placing the number 10 in front of the parentheses, we made sure that that division would work. But this is where this plan to me takes maybe a bit of a nasty turn. I also now, well, no, never mind. I take that back. Let's keep going. So we copy down the plus 15. Let's do our second distribution right here. Follow the first purple arrow. What's -5 times -3x? Positive 15x. And again, you got to know your basics. Second purple arrow, watch out. There it goes, there it goes, there it goes. What does that equal? You really should focus and don't daydream. It's a positive because it's a negative times a negative, and the 5s cancel each other. And what do you get? You get +1, and then you copy down the -5x. That felt really weird to me. That's your thing. That felt real clunky to me, but it also might suit some of your needs. Bottom line at some point is you have to face the music and say, I know how to work with fractions. And I say work with them, and really you're just destroying them. It seems a little hostile, but that's really what's going on here. And we can finish this problem, and I totally will, because I don't want to leave this stone unturned. But you do understand that from this point on, if you're confused, it has nothing to do with what we're doing in class right now. It's stuff we did 2 weeks ago. Fractions are dead. Let's press on. So on the left side, what can we do? Yeah, let's combine some like terms. So we wind up, I'm going to start writing up here in this upper right corner because I'm out of space. So I'm going to copy down the -5x, and I'm going to add my 12 and my 15 to get 27. Now on the right side, what do I get? (15x minus 5x is 10x. And you realize now, wow, I've been here before, right? Like this is totally, I'm right back in my super comfy wheelhouse here. I'm going to add my 5x to both sides. I'm going to skip a little bit of work here, and I'm just going to put 15x. I'm also going to subtract 1 from both sides. This is where we'll get to here soon, is where you stop showing all the work, right? You see yourself adding 5x. You know you're adding 5x. You own that you're adding 5x. Subtract 1, and then we divide by 15, and x equals 26/15. Final answer. You see now that the fraction killing process is much more intricate than it was yesterday and Thursday. And again, as always, delta wants fractions. You know, don't put in some 1 point blah 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 thing. No one wants that garbage, right? You just leave them as fractions, make sure they're reduced. That's that. How'd that go? Rough? Easy? I'm going to continue with the first way. I'm sorry, Alana. I'm going to, because I think that the masses are saying that the first way was much more palatable. I know. And you're tough. You're doing a great job. I have faith that you'll get it right either way. So let me erase this. Should we check our answer? I'm scared. Should we try it? I'm scared. Should we all be scared? We did it. All right, let's do another one. So this is just how I'm going to keep going here with you for a little while. By the way, lots of notes today. You, of course, know that tomorrow will be a full workday in class. and Friday probably, or Thursday probably would be too. These are hard, and I'm going to ask you to do 20 or 30 of them, and they take a few minutes each. So plan tomorrow in class. I'm going to eat up most of your time today, but tomorrow plan, come in, flip open your Chromebook, except maybe there'll be a snapshot. Other than that, work day. So, all right, so this time, let's just do what we did the first time. Let's not prep it to kill. Let's just accept what it is and distribute. And so what that means is this -1/2, I'm going to circle him in red, is going to distribute here and here. So I'm going to copy down my -1/2 from the beginning. I'm going to copy down my equals sign. I'm going to copy down all the things that don't get to play in round one. Now you focus on where those red arrows are. The first red arrow is a negative times a positive, so I can go ahead and get the negative part out of the way. And I'm always intrigued by what kind of answers I get for this, and I'm happy to provide a short basic skills lesson. What is 1/2 times 4/5? In its raw form, just let me show you it in its just bare, naked, raw form. 1 times 4 is 4. 2 times 5 is 10. Done. That's how easy multiplying fractions is. But you heard from the back of the room, one person said 2/5. And that could have come from either him figuring out that it was 4/10 and reducing it mentally, or he could have gone back and said, I'm going to reduce this 4 and this 2 before I multiply. I don't know which one he did, and I don't care. But at the end of the day, we do wind up with -2/5. Siempre reducir fracciones. 100%. Siempre. Don't go monkeying around throughout the problem where you make big fractions, and then you got to deal with it later. Reduce them as you go. Now, let's do the second distribution. I've made an absolute mess over here, right? Oh, my goodness gracious. Now we're going to take this -1/2, and we're going to multiply it by 1. What does that equal? That's just -1/2. That, to me, is the part where I feel like kids have the most pain. And if that's not painful for you, then we're going to have a really good few days. So now it's time, let's kill some fractions. Oops, I forgot my X, didn't I? I apologize for that. Let's kill some fractions. What should we multiply by? 10, I agree. Let's stick on our monster brackets. Let's multiply by 10. How many places is that 10 going to hit? 5, all 5. Everyone is out in the open. It's open season. So here it goes. Follow my purple arrows. What is that first answer right there? -5. Now on this one, I'm going to teach you that fish hook thing again. I'm going to try to keep using my hands to show you how this next part works, because this is nothing that requires showing work. The 10 is a high 10, and the 5 is a low 5. Divide, and then hook your answer back across and multiply. What is 10 divided down by 5? What is 2 times 2? Easy peasy. So we just put -4x. Man, that's slick and easy. You got it? Yeah, boy. Let's do it again. Copy down your minus sign. And what is 10 times 1/2 again? Yeah. Now, in my line of work, usually I see, and I understand, if you're proud of that, you should be. It's good to celebrate. You don't just celebrate football and basketball and volleyball. You celebrate when you understand math too. And if you understood that, good job. But don't pat yourself on the back so hard that you forget this and this. Everyone is getting multiplied by 10, and so equals -20 minus 30x. Sometimes we prematurely celebrate. And you're like, whoa, there's no more fractions. So let's do it. What do we get? I circled some like terms. -10 minus 4x equals -20 minus 30x. And look, oh my gosh, I've seen this before. Who should we move? Don't you start with the 20 and the 10. Those numbers are dead to me. We should add 30x. Negative 30x is a whale of a lot smaller than negative 4. I elect, since I'm the guy with the fake pen, to add 30x to both sides. And now I'm left with negative 10. How many x's will I have? Plus 26 x's. We are deep in it now. Next. Add that 10 to both sides. So we're going to get 26x equals negative 10 because I added 10 to negative 20. Last step. Divide both sides by 26 and we get x equals negative 10 over 26. And I feel at this point like I so badly want to type that in because I rock, man. I killed fractions. I combined like terms. I moved my x's. I moved my numbers. I divided. I'm like, yes, that felt so good. Why is it wrong? Because you got to simplify, reduce. So the answer I'll actually type in, I'm going to write it in green here, is negative 5 over 13. The moral of the story today is the fractions are going to hide from you. And if you're ready to, you just step up to the plate, accept that there'll be one step of physical discomfort, and then it's business as usual after that. Should we test that one too? All right, you're not scared? I'm scared. I'm always scared. I make mistakes just like you guys. But I'm not. We're 2 for 2, guys, gals. We're kicking some booty. Let's go. Let's try this one. We'll do a couple more. What do we love about this problem? Come on. There's only one set of parentheses and what's in front of it? A negative. So I don't even have any stress about fractions. This is one you're going to come to know when you see it coming as, haha, that's easy pickings right there. That's light work. So I'll let you copy it down, and then we will work our way through. I'm going to copy down this negative 1 because it doesn't get to play. And I'm going to distribute my negative. What's going to be the result of distributing this negative sign through here? Negative 3/2 of x plus 1. And the rest of it just gets copied down. Wasn't that pleasant? Not all problems are created equal. This one is a joke. Can anyone see anything really rad that we could do before we decide to kill fractions? We could multiply by 4, but that's killing fractions. Do you see anything else? The math gods threw us a little bone here. Which ones? Ooh, look at this. And every once in a while, you see this coming and you're like, this is actually worth my time. What happens if I add this -1 and this +1? They just go away. So really, my problem now just says negative 3/2 of x minus 9x equals 3/4. And I wouldn't advise you to combine those like terms because then you're back in the danger zone. It's time, let's just make our lives easier and eliminate these dumb fractions. What do we multiply by? 4. I'm going to keep practicing this with you. And I know that there's 8 of you in this room who don't understand what I keep doing with my hands. And I need you to speak up or come see me if you're bashful. When we multiply, we're dividing by the bottom and then grabbing that answer and then multiplying it back across the top. I used to call it the hook because it looks like a fish hook. When you divide and multiply like this, you go divide and multiply. Do you see how it kind of looks like a little hook that you'd get stuck in a fish's gullet? You see it? It's neat, right? That's how fraction killing works, is you divide and multiply, divide and multiply. So let's practice. What are we going to multiply by again? 4 is our guy, so let's multiply by 4. Here we go. Do the hook. 4 divided by 2 is, swing it around times -3. You get negative 6x minus 36x, says the voice of reason from the back. Don't forget, you have to multiply everybody. Just because you're fraction killing doesn't mean you ignore all the other guys. And then let's swing it all the way across over here. That's beautiful. What happens on that one? It's just 3. No hook necessary there, right? The 4 is just poof. Combine your like terms. How many x's do you get? Negative 42. Next step. Divide by negative 42, and this is going to be a little bit ugly. So here's my answer in its unacceptably raw form. Ugh. What can you reduce 3 and 42 both by? You can. If you divide them both by 3, and you can use calculators for stuff like this. Like most ninth graders are like, I don't know 42 divided by 3. That's okay, but your calculator does, and it's 14. Smack on the nose. So we wind up with this gorgeous little fraction, x equals negative 1/14. Should we try our luck again and type that in? My gosh, you think we can go 3 for 3? Ooh, negative 1/14, right? Come on. Here goes. For 3. Next one I pick, you guys are doing, and I'm not going to help you. Are you scared? Oh, are you scared? What's the matter, Colonel Sanders? Chicken? Gosh, if only there were some seats closer to the board. Let me see if I can free one up for you. Oh, there you go. Yeah. Come on, get in there. I once got feedback from a student who said, Mr. Ahern, I would learn more in your class if after you do some examples, if you'd let me try one by myself. And I was like, that's a wise kid right there. So I'm taking that kid's advice. Good luck. And if you get it wrong, we're all going to point at you and laugh and make you feel stupid, right? Yeah. Rogue, no, that was a joke. That's not what we do. We'll just point at you and laugh and support you. There's this 91.2% chance you're going to get this wrong, and that's totally fine. But if you don't try, you won't know. GB, can you see from right there? Is that better? All right. Scary, isn't it? Just think in the next assignment, you get to do like 20 of these. And yes, you could type them into some website that will solve them for you. But what's the point, right? Because then on quiz day, you're like, oh, I don't know what to do. So this will be a long couple of days. Be prepared. But you're going to be so good at them. You're going to be an expert. I'm going to work it out in secret up here on a note card, and then I will know what the right answer. Yeah. You're right, man. I'm sorry. Yeah. So I want to know what the answer is. So as you guys are telling me your answers, I'll know whether to point at you and laugh or be supportive. Well, this one actually isn't very bad. That first step was a breeze. You guys like that first step? Yeah, it's easy. You got this. All right. I know the answer. Waiting on you guys. But you have to be the first person to give me the right answer. I'm ready. It is not. Unless I'm wrong, which Lord knows has happened many times before. Yes, ma'am. That is not correct either. For the record, both of your answers lead me to the conclusion that you're definitely on the right track. So there's goodness in both of the things you guys said. There's potential. Landon's got an answer. He's not sure if he wants to raise his hand or keep acting like he's itching and scratching his eye. He's like, do I go full send? The fraction, when you see it, you'll realize right away cannot be reduced. It will be a fraction, and it is in. You'll know right away. I'm ready. No, that is not correct. That is wrong. Tyson. No, it's not even close. Alana. No. Senora?
-54/24?
No. He's not. It's not right. No, it's wrong. Because I said so and I'm older than you? No. No, I'm not. I know the answer. It's right here. It's on my note card. All right, let's do. The clock is my boss, and the last thing I want is for this class to end and we're not done with this problem. So I'll give you 30 more seconds. 30 more seconds. Go. It's not one. It's a fraction. It is. No, it was already said once. That was Mila's answer. It's not 16/9. I can tell you, I think I know where some of you messed up, but let's run through it. What do you keep barking orders at me for? That's my boss. See that round thing on the wall? It waits for no man. It's not going to care at 8:45 and say, oh, yeah, you can have another couple minutes of first hour, Mr. Ahern. That doesn't work that way. I can't pause. I'm not like. What's the worst that can happen? It's wrong. That is incorrect. Yeah. Let's do this. Let's light this fire. And some of you in step one might already see where things went south. So here it goes. I'm going to distribute right here, and I'm going to get -2x. Are we good so far? That's just a third times 6 is a third of 6. 6 divided by 3, however you want to say that. And then I'm going to distribute right here, and I'm going to get -2. And then I'm going to copy down my +6, and then I'm going to distribute again. These are nice distributions, really, because the 1/4 is annoying, but he's multiplying by ones. And so things don't really change. I get a negative times a negative is a positive 1/4 of x. And then on this second one, a negative times a negative is a positive, and 1/4 times 1 is just 1/4. And then I copy down the -1. Are we good so far? If you made it this far, I would be surprised if you then missed the problem from here, because what happens now is we kill the fractions and we just multiply this whole equation by 4. How many places is the 4 going to hit? All 6, right? Everyone is out and exposed. And so the 4, here I go, I'm going to get -8x -8 + 24 equals 1x plus 1 minus 1. Minus 4, excuse me. Got it? So that's just sweeping through times 4. That's just all the multiplications happening. And then from here, it's time to combine like terms. So I'm going to do negative 8x plus 16 equals 1x minus 3. The answer is about to appear. You'll see it happen. We're going to add the 8x across to the right, giving us 9x. We're going to add the 3 across to the other side, giving us 19. And the answer I was looking for was 19. Nice. You can see this is going to be an adventurous couple of days. I am going to put the next assignment is on Delta. I have a due date on it. The due date on it is Monday. So we're going to have some time to hit it in class. So start it today, tonight, if you want. It's up to you. Maybe you can challenge yourself to get 1 or 2 right tonight. What'd you do?
I forgot to change my.